Welcome everybody. I guess I have to click this button again to start. Yeah, you see. Welcome to my talk. The title of this talk is called Tackling Component State Reactively. The first title was Tackling Ephemeral State Reactively, but then I was like, ephemeral state is maybe not the most well-known term, so I stick with component state. And I want to start this talk with a quote from the Gang of Four. If you stick to the paradigms of object-oriented programming, the patterns appear naturally. This is from a book from the Gang of Four called Design Patterns, and I want to stress the bold statement a little bit more. The patterns appear naturally. What does it mean? It means they did not put a lot of effort in inventing something new. They did not sit down and think forever to come up with the perfect solution. They just stick with the paradigms what object-oriented programming gave them. And in the end, all their patterns that everybody nowadays uses appeared naturally, effortless. Let's start. I have four-ish sections. I will talk a little bit about the terminology because local state or component state or ephemeral state is not a well-known term. Maybe in modern things like Flutter they have it built in, but in all other frameworks, at least the reactive part of this local state management is not really well known. So I will speak about the terminology, how you can understand it, some concepts, some ways to get names for all those things. Then I will introduce you to problems, a set of problems that you will experience when you try to implement your state management in a reactive way. I will talk about ephemeral state management in general. In particular, I will show you the solution that I come up with, and you will also get a live coding session so that I not only talk about this stuff but also show you some hands-on experience. Let's start with terminology, and I will give you a small map. Here we have layers of state. And I want to start with the very left side, from your perspective, the left side, yeah. We have like persistent server state, very long-living data, I would say. They are on the server and they don't care if your client is online or offline or exists or not, the data is there. And it is not so easy to get rid of it. You have on the other side client state, and this is all the data and all the state that lives on your machine for more or less time. And I subdivided it in two categories, persistent state and ephemeral state. And for persistent state, we already have some ways to manage it. In the Angular ecosystem, we have Ngrx, we have ngxs, akita, all those global state management tools. Some people call it the Redux pattern, even if Redux is not at all a pattern. Yeah? If you want to mention a pattern, you should mention CQRS. Maybe this is close enough, or a commander pattern, but Redux is not a pattern. And then we have ephemeral state management, and nobody in the Angular community ever tried to really manage this state. What does ephemeral mean? I give you the German name, vergänglich. Yeah? Ephemeral state is state that disappears after some time. And this is the section that I want to talk about today. What is ephemeral state? I give you a small diagram. At the very top, we have global state. We have our global store. This could be your Ngrx store or other global services. Then we maybe have some browser plugins that are here. Yeah? The Bluetooth plugin, the URL bar, all those stuff is here and stays here and is like globally available for any line of code in your application. And then you go down, you're in a component-oriented framework, and you have components that consist of components, and somewhere in between you have this yellow helmet. And this is the state of some subcomponent, of some child component that is only important for this single component. Not for this, not for anything else. So it is scoped. And the lifetime of this data is also tied to the lifetime of the component. So this is a small diagram that you can understand what local state really means. My name is Hladky. I do trainings and consultings in the field of Angular. My hobby is maybe the most complicated topic in Angular, it's RxJS, but my money is earned by Angular, so I can only recommend to book my trainings and consulting. I made great experience joining it and attending it, so maybe you do it too. Terminology and categories. How can you divide persistent and local state? I ask 3 questions. I ask about accessibility, lifetime, and the processed sources. What does accessibility mean? This means that a certain part, some data in your application, is globally available. Every component can reach it. Every module, every service can just reach it and do something with it. Locally accessible means the data are only accessible within some scope. Maybe some child service, maybe some child component. Then I have lifetime, and there we have static and dynamic lifetime. Static lifetime could be the lifetime of the app itself, where it more or less is like static, because you have the beginning of your application when your browser boots, and you have the end of your application. And on the other hand, on ephemeral state, you have this dynamic lifetime, which means maybe this state never appears in your application, maybe only for 5 minutes or only for a few seconds. Then we have processed sources, and here I also divide between remote sources and local sources. I will go into a little bit more detail that you can get a better clue what all those questions are. I start with accessibility. And here I show you what global accessible data means. I have a singleton service, and every component is interested in part of this state of the service, and as there are multiple interests, it is shared. It is shared between multiple applications. What is local accessible state? Maybe it is partially related to some global sources, but the really important part here is that you don't share the state between components. Yeah? It's only for one component. What is a lifetime? I show you an example for static lifetime. The blue line at the top is a singleton service in Angular. And this service is here before your app component is here. Yeah? We have dependency injection. Dependency injection is lazy. So if I want to inject a service into my component, it has to be here created, instantiated before the component exists, right? Makes sense. So at the very beginning of my application, the component gets instantiated, and at the very end of the application, this component gets destroyed. This is static lifetime. What is dynamic lifetime? If you think about some local services, some components, directives, pipes, other snippets of your code that are not in this DI layer where you have only singletons, and as you can see, beginning and end varies, and you can realize that this is more or less dynamic. Let me give you a better example what dynamic lifetime could be. Think about an async pipe. An async pipe has only a very, very specific range in which it lives, right? Only after the component template expression is evaluated, it bootstraps, it kicks in, it displays some value, and after the component, at least after the component gets destroyed, it also dies. If you stress it a little bit more, you can think about an ngif wrapped around your async pipe, then the lifetime is even more dynamic. You can display and hide it a couple of times while your app is living. So this is dynamic lifetime. What are processed sources? I never gave you any example what sources are and locally global sources. So these are like global sources, remote sources. I call them remote because they don't live in my application. And with remote, I not only talk about sockets and stuff that is really not on your machine, but on another machine. I also call remote sources maybe the InexDB or the local storage in your browser is also remote because it's not in my application. And these are global sources. What are local sources? Local sources are click events, scroll stuff, a timer, something that lives only inside your component. And local state processes mostly local sources. So this is like a little bit of terminology that you understand what I try to explain. The next thing is I want to introduce you to problems. Yeah? Assume you wanna create some logic that deals with local state. If you try it, you will run into some problems, and they are pretty interesting. So I list the problems here, and I introduce you to every problem step by step. This is an overview. Timing is like the overall topic. Then we have sharing work and instances. We have some subscription handling. We have the late subscriber problem. Then I will talk about subscription-less interaction with global and local state, and some parts that I will not discuss today, which is like protection against misusage of your local state management and cleanup of that state. This is pretty interesting. So if your component dies, the state is gone, right? But if you manage it in your global state, and this is, I assume, what everybody here is doing, your component dies and you have to clean up state. If this happens, set it to false again. If that happens, set it to true again. I will not talk about it, but just keep in mind that there is this problem of cleaning up the state. Timing. So timing is really complex. This is a chart of the life cycle hooks of a component in order. It's a lot, right? So there are several, and I'm not sure if everybody can name it by heart. Can anybody name all the life cycle hooks by heart? No. A lot. Now imagine a step further. A Hello World example of Angular looks like that. You have not only one component with life cycles, you have several components that have life cycles, pipes, directives, whatever. And if I want to retrieve some state from my global service to my local service and display it over an async pipe, this is what happens under the hood quite a lot. All the timing stuff leads to one of my first problems that I want to introduce. Subscription handling. Subscription handling is like one of the really essential parts of my solution that I present. And I show you what I suggest that you should do and what I guess that you already do. If you have an observable in your component, you receive it and maybe you subscribe to it in your ng on init stuff, right? If you don't work reactively, you always have to mess around with these lifecycle hooks that I in general don't need and use. But if you work not reactively, you need them. And then you put it in the ng on init or in the constructor and you subscribe to some global state, for example, your store, your URL, parameters, whatever. And what you do if your component dies is you unsubscribe. Normally you have some snippet of code in your ng on destroy block that says if the component and this gets destroyed, I unsubscribe from the observable that I was interested in. I will show you an interesting solution. On the left side I have my ng on destroy subject, here I have my ng on destroy hook. This is, I guess, more or less well known. Whenever ng on destroy fires, I next. This nexted value is put here in a take until pipe, and this means that this observable here lives until ng on destroy fires, which is whenever ng on destroy is called. I guess it's not that hard to grasp. Now take a look at the first line. Export class service. It's a service, it's not a component. Also services have lifecycle hooks. The ng on destroy lifecycle hook, for example. With this in mind, we go to the right side, and what I do here is, instead of only injecting it in the constructor, I also placed it as provider, as local provider in my component. What does it mean to place a service under the local providers? The lifetime of the service here is tied to the lifetime of the component. So if my component dies, the instance of this service will also get destroyed. In opposite to global singleton services. Okay, and now take a look at the logic. Here I have a subscribe function that gets an observable passed, and inside I subscribe until ngxs is called. On the right side, I have some observable, and I use this service and leverage the service subscribe function and just pass the observable to this subscription handling service. As you can see in the logic here, there is no subscription that I hold and there is no unsubscribe. So subscription handling is pushed into this service layer, invisible from the component here. It's pretty interesting and pretty cool, and this is one of the essential parts of my final solution. The next problem that I want to introduce you is sharing work and instances. Let's talk about some fundamental principles in RxJS, in reactive programming. There are unicast and multicast observables. What is a unicast observable? A unicast observable means everybody that subscribes to this observable gets its own instance of the subscriber, gets its own subscription, and every process is executed for every single subscriber. So if I have 10 subscribers, the process is executed 10 times. If I have 1 subscriber, it is executed 1 time. Compared to multicasting, where I have a single source that emits the value to multiple subscribers. In this case, no matter how many subscribers I have, it's only executed 1 time. And this is pretty interesting for 2 reasons. The first and easier reason is, if I have like heavy processes, think about something from your real life projects, calculating a prime number. I'm pretty sure in every of your real life projects you calculate a prime number, right? And those prime numbers are mostly not that easy to calculate, especially if they get longer, so it takes computation power. If I'm a unicast observable, I will execute the calculation of this prime number for every subscription. So if I have 1 subscriber, I execute every single operator 1 time. If I have a second subscriber, I execute every single operator 2 times. And now think about 10 subscribers and 10 times this real life prime number calculation. That is nothing that we want to have in our application. We want to share those work, we want to share the calculated data and the work. The second thing is sharing a reference. Here it is not interesting to like save some computation power, it's only interesting for us to retrieve the same instance. Maybe it's not a common thing, but you could generate objects on the fly, classes on the fly within your stream. For example, I can dynamically generate a reactive form on the fly from other streams, put it in a template and emit its changed values. And if I have 2 subscribers on this form, I want to have both subscribers to receive the same instance, right? Because otherwise you will run into some problems. I will show you quickly what I mean. I have here some demo. There should be a form. Okay, here I have forms. Yeah, this is a completely normal form. And if I type something, the value date is updated. If I generate the form instance over some streams and I type, excuse the marking, you see nothing happens here, no updates. Because one time I subscribe in a template and the other time I return the values of these value changes from my reactive form. And here I did not share the instance, and only if I share the instance or the reference, I can type, and then one single instance of this form is present and it works again. So this is sharing a reference, an underestimated problem. Okay, so I have reuse of work and computation power, or reuse and sharing of an instance. And what we do to solve is we, for example, use a share operator, an operator that enables you to hold a list of multiple subscribers and forward the same value to multiple of those subscribers. The next problem, also a really cool problem, is the late subscriber problem. What does the late subscriber problem mean? You have a stream of values, and for sure there is a time of subscription, and for sure there is a time where you unsubscribe from this observable. And depending on where you subscribe or what you try to receive, you could miss data that are emitted before you subscribe to it, or you can miss data that are emitted after you unsubscribe. So this is the late subscriber problem, and it is a pretty common problem within Angular. I give you a real life example. Here I have a component and an input binding, and whenever my input binding receives a new value, I have a subject here and I next the incoming value to this subject. And here in my template I just use the async pipe to subscribe to this subject. So do you think this code is working? It makes sense, right? It's correct code. I display it, I subscribe to it, async pipe unsubscribes after the component is completed. The problem is, it is not working. ng on init, or even before the input binding, fires, receives the value, emits the value, but your template expression for the async pipe is executed way after. So you never see any value. I demonstrate it again. I have some demos here so I can really show you that it is not working. I go here and I search for late subscriber, and you see here there is a null because here I used a subject, and here is a value 1. I did something different there. Why did it work on the second example? I show you. I used something that most of us would use after some point. They use a replay subject, right? Put a replay subject in and the stuff is working. We just re-emit the latest value 1 here. Yeah, I store the last value, and then whenever somebody subscribes, I re-emit the value, and magically the value that I received and cached when my input binding was set, I can replay the value whenever my template expression is firing. Is this a very good solution? Would you implement it in your project? You say no. Why would you not implement it?
What if I change the value in a life cycle after the input? So the first value would never be received.
Exactly. One limitation is I can, in this case, replay the first value. Let me go back. What if I delete the 1 here? And I re-emit every value? Technically, it would solve your problem. I mean, let's don't talk about performance in this case, yeah. But technically, it would work, right? Still, it's not a good solution. And I will show you the full scope. There are 2 caveats. One caveat is that we push workload to all our consumers. Yeah? If I want to create a state management library for ephemeral state, and I force everybody else to replay whatever how many values, that's not a solution that I would use, right? So you should take it over. You should do the work for everybody. This is not the most critical stuff. The really tricky part of this is that our composition, like we want to manage local states, so we have to compose 1 or maybe 2 sources with each other and manage an object which is my local state, the state of the component. And if I do this, I have my composition cold. My composition relies on the consumer to get triggered, to get started, and I will miss a couple of values, maybe all. I will demo something. I have a replay subject implemented, so the first solution where we would say, okay, yeah, it's working, let's go with it. Cold composition is here, and here I have some boxes that show which state I manage. I click and my state is very simple. I have a sum, and the sum counts up. Very, very simple. And if I click this switch here, there is an ngif wrapped around this object here. And if I click this button, I execute the ngif and the component, the HTML gets removed. And if I click this again, it reappears. And here, I did not use a replay subject, I used another technique. And what is here? Here, I used the approach that everybody would use. If I click this and the ngif disappears, what will we see? Null. Did you expect a null? Again, manage my state. I have an ngif. Null. This is not working, right? Nobody can write an application that loses the state whenever an ngif triggers and I resubscribe. So I guess it shows in a very good way that you should never rely on your consumer. You should own everything. I give you more graphics that you understand what I did. I can also use a replay subject instead of a share replay operator instead of a replay subject. Still the same story. My consumer down here rules everything. My consumer, whenever my consumer wants, subscribes to the observable, initializes it and starts to compute the state. Yeah? Whenever something is emitted, I take it, I merge it into my state object, and I re-emit the state object. And if I unsubscribe, maybe ng on destroy, or as I demonstrated, somewhere in between with ngif, and resubscribe again, share replay does its job after the last subscriber unsubscribes, is basically loses its state until the next subscriber subscribes. It's still cold, even if I use a share replay subject. I have a cold observable and my composition is cold. What is the solution? We need a hot observable, and in this case one solution is the publish replay operator. Publish replay is very similar to share replay, but the big difference here is I can call connect, and when I call connect, it's hot, it's started, and I own it. I call connect. Whenever I call connect, this observable will always be hot, will always compute the state, and as you can see here, who rules this observable? The blue part. Our provider, the local state service itself, rules the whole state, and this is also the reason why in my demo, here at the bottom, the state is always there, no matter if I use the ngif or not. I don't lose my state. Very, very important. Essential part of my solution. Okay. What's next? Subscription-less interaction. I already showed you how I manage my subscriptions. I got rid of the unsubscribe call. Nowhere in my application there's an unsubscribe call. But I have a .subscribe call, right? Before. Now I show you how to get also rid of the subscribe. The first thing that we need to think about is what does it mean to code declarative or imperative? Ngrx, yeah, a tool that manages our state and we can retrieve the state in a reactive way, is pretty imperative when it comes to change its state. If I call a .dispatch method and I dispatch an action to my Ngrx store or to any other global state management tool, this .dispatch, I could rename it to setState. because this is what I do. I imperatively call a method set and forward a value. Or I imperatively call a method get and get a value. So imperative programming is all about setters and getters and mutating state. Maybe you realize that this line of code here is not composable. You cannot do anything with it, right? If you want to do something reactive, you can, well, do nothing. This is the problem. I cannot really compose setters and getters. I cannot compose a function. A function is not composable. I give you some more real-life examples so that you know why I believe this is so important. I have 3 different streams, my router state, the URL, that gives me some parameters. Maybe I have another global state tool here, and then I have some input bindings, the input bindings of my component. All of those things could be streams. How I would work with those streams if I had to work with setters and getters, or the dispatch method. I have to subscribe to them to perform a side effect, and for every subscription I have to manage the subscription and call take until. Every single subscription I have those 2 lines here, and the only thing that I need is something that receives my state. So a lot of overhead and a lot of options to make failures, because maybe not everybody is that good in subscription handling. I'm not. Last time I searched 1.5 hours for a bug, which was forgetting to subscribe. I worked with RxJS for like, I don't know, 2013, and I still forget to call the .subscribe call and search 1.5 hours. So you can do a lot of stuff wrong when it comes to subscription handling, no matter how good or bad you are. Doesn't matter. You will at some point make it wrong. I will show you diagrams how this subscribe and set state looks. Yeah? I have my observables here at the top, and then I have this pink line that says setter. And this pink line breaks the reactive flow. I have to call .subscribe to my observable, and whenever I call .subscribe, I'm out of the reactive world. I cannot do anything, because in my subscribe block I can put a side effect but nothing else. It's not composable anymore. And what we do is we call .subscribe, the pink line appears, and then we call dispatch. We send a value to another service that calls .next on a subject. We break the reactive flow, and we have a lot of overhead and a lot of points where you can make stuff wrong. Here, in this case, I have my scan operator, and this is the state accumulation, and then I emit the state, just that you more or less understand what all those lines, colors, and shapes do. These are values, the circles, and the shape, the squares too. And then I have operators, a subject or a scan operator, and here I subscribe. And there is the break where I say .subscribe and call the dispatch method. So what could be a solution here? A solution could be to work with higher order observables. Observables of observables. You can go any order, so it's called the order of observables, and you can have a first, second, third, fourth order observable, and in my case I have just a second order observable. But all those orders are like reduced to the word higher order observables or higher order operators. In this case, my observables, you already know them, are the router state, the global state, and my input bindings. And look at this part here. What are the values that are emitted from this stream slices $? Not objects. The whole observable is emitted as a value in this stream. The pink box is an observable for router, for global state, and for my input bindings. And the key solution to this is use the merge all operator. What does the merge all operator do? It takes a stream of streams, or a stream of stream of streams, or a stream of stream of stream of streams, yeah, whatever. It takes a higher order operator, observable, subscribes to every single observable inside, and forwards, or in this case, merges all the emitted values of this first observable into the output stream. And then I receive a new observable. Inside, I subscribe to it and I re-emit all those values. So the subscription is inside of the operator, hidden, and I can pass as many observables to this slices stream that I want. If I show you the full picture, this pink line disappears. No break, no break here. I always can stay in this reactive way of programming. And this is not only a nice graphic, the important, I hope it is nice, yeah? But the important part here is there is no pink line. The pink line was calling .subscribe and set state or dispatch action, and this disappeared completely. If I show you the code now and you look at the right side, you see one method call and the observable. That's it. There is no subscription anymore. I basically don't care who is doing whatever with this observable. I just forward it. I say, I have this observable and I want you, whatever you are, and I call it ephemeral state or local state or state service. Whatever you want to do, take this observable and do what you want to do. And what I do is, I take the observable, put it in a merge all operator, internally it subscribes, and then I merge the values. And in the end I also receive a state object, but this time without subscriptions. So this is pretty cool and very little code. Those were some problems that I wanted to show you. In fact, I had like a couple of more problems to solve when I did the research, but this is like more or less the essence. If you grasp those problems, you basically understood everything. I will show you the first draft, a first solution, which combines all those different problems and, of course, not the problems, but their solutions in one single piece of code. You remember the quote, if you stick to the paradigms of object-oriented programming, or in my case it was reactive programming, the patterns appear naturally. I had all those problems, I had a really big list of problems, and I solved every problem completely isolated. I never thought about, but then I could also do this for the other problem. No, I was like, I have my list of problems, I solve those problems isolated, and really stick to the rules. And when I was done, I was like trying to merge all the solutions of all those problems together in one code piece. It wasn't that hard. It was basically already here when I was done with solving the problems. And funnily enough, it was also not a lot of code. These are less than 15 lines of code that solve all the problems that you may run into when you code reactively in not only Angular, but a component-oriented framework. So this solution works for every framework that is component-oriented. This is the API. I have set state. You maybe know it under the name dispatch, but I don't need an action. So I just call it set state. This is an imperative way to code. Then I have connect state, where I just forward an observable. Instead of setting an object to my state, I forward an observable that emits state objects that get merged. Then I have something that is called here connect effect, but in fact I should call it hold effect, because this is a way better name than connect. So let me quickly rename it to hold. So I have the hold effect method, and then I have a select. Maybe you are familiar with select from databases or from your Ngrx store. You basically pass something into this function, and it returns an observable with a particular part of your state, with a state slice, or to be more technical, with a derivation of your state. Before I give you more theory, I maybe show you how to use this local state management and how it feels in practice. To do this, I just need to find the right example, and I guess this is it. And if I go here, if I go here, sorry. So what I want to do is, I want to create a component that holds a list. This list is coming from a backend, and I can fetch it over an HTTP request. The list has a refresh button. If I click the refresh button, I basically fire an HTTP request to the backend, retrieve the new state, merge it into my global state management. The global state management re-emits the state, and boom, I receive the new emitted item here. I can also do more. I can select certain parts of this stuff, and those selection is then visible in my output. So my component outputs the selection. And the last part is that I have a side effect, a background process that basically is a tick, and whenever the time exhausts, I trigger the refresh to my backend automatically, and the new item arrives. So a very, very primitive and simple use case, I would say. Not a high technical stuff, but just that you see how you would manage this part of your application. What I do is I double check if I'm in the right project. Nope. Then I switch to another project, and this looks better. Okay. This is my HTML, and there is no RxJS anywhere. Yeah? It's very simple. There are only two things that you need to know. I have M is like my model, yeah, the object that describes the whole state of my component. And for every button, click, or interaction, I use subjects. And whenever my button is clicked, I have my refresh clicks subject, and I next the button click event. I guess it's digestible. Here is my M, my model that holds my initial component state. And what is my initial? What's the shape of my component state? I have a refresh interval, which is a number. In my case, 10 seconds when I initialize the component. I have list expanded. This, I didn't show you. So the list can be expanded, collapsed, whatever. And this is also some state that I manage. And then I have the list itself, an array of entities. And I want to introduce my local state management in a reactive way, because I'm not sure, do you even know why your changes are rendered in Angular? Do you know how it happens? You have no clue, right? Me neither. I mean, now I know it because I studied this Zone.js stuff, but I believe it's a very bad thing that we have Zone.js, because nobody of us knows about how Angular is rendering the state. Right? We don't know it. Nobody knows it. Very bad. With this approach, and if I code reactively, I know when I render the state, because I have this async pipe, and if I open up async pipe, I see a method there that is called detect change. So whenever an observable emits a value that should get rendered in my template, the async pipe receives the value and says, render the new state to the template. So this is something we understand, right? This is easy. Zone.js is not easy. Or is it easy? I mean, I don't get everything from Zone, and I read the whole code 5 times, and I talked to Chailia, the maintainer of Zone.js, and I still don't get it. Not fully, right? So what we do is we try to switch from this imperative, zone-full, unreactive way of coding to some reactive stuff. I have this component, this service that I call local state. And my local state is typed with component state. Yeah, the interval, the refresh interval, the list, the expanded state. And this local state holds it, and I extend from this local state to my component. I hope nearly all of you will say, oh my God, how can you extend and go stick with inheritance? Excuse myself, it's just for this very tiny example easier to grasp, but you can do way better. I will show you later on. So I extend the class with this component, and then I have my M, my model here, and this model is basically filled with the initial state. The first thing that I will do is I will rename the M to $, and here I will say this, and this is the component and also my local state. So this has a method that is called select state, right? And if I don't put any queries into my select call, I receive the whole state object itself. In my constructor, I say this, because this is also the state, set state. I know it's not reactive, please excuse. But just to show you, I can also code reactively. Initial, what was it called? This dot initial state. Are you sure? I'm not sure if you're right. No, you're wrong.
Sorry.
He was wrong. Here it is. It's here. Yeah.
You're right. Sorry.
No problem. I love to make mistakes, and I hope you do it too. This is a set state. Now when I call init component state and set my state, I should receive something in this observable here. How can I rewrite the whole template to be reactive? It's a lot of work. Please be very careful and look what I do now. I put here a very dirty hack. I say ng if in the future we will get a directive that is called let directive or ngrx let directive, stuff that I'm working in at the moment. And we will ship it, I guess, with Angular 9.1. But at the moment I use ng if, and I use the async pipe to subscribe to it. And then I say as, and then I store it under the variable that is named m, exactly the same name as my model was named before. It was just a static object. And this is the way how I refactor my whole template. So now I have everything refactored in my template, and I should see if my component is still working. I just switch to the right application. There is a red line. It refreshes. And there is no error, which is pretty cool. And now I can open and close my component, and this initial way of retrieving the state is done. Okay, I have done this, I have initialized it. Now let me connect input binding. So how do I get my input binding, which is definitely not composable, because a function is not composable, we already know it. How do I connect this uncomposable method with my state? Uncomposable stuff, you can fight uncomposable stuff with other uncomposable stuff. You can say this set state are also not composable, and then you can set the state. Whenever my refresh interval setter is called, I re-emit this value. There is a red line. Why? Because I cannot emit values to my store, I should emit structures, state structures to my store. And in this case, I emit an object that holds as a key refresh interval with the value of refresh interval. So this is now a state object, a state slice that I emit. The second thing after I connected all my input bindings is, finally, how to use this connect method, right? Now we are starting to really leverage the power of this stuff. I have something that is called store. And my store has a select method, and this select method can take a selector. Let me quickly think what I want to select. Repository something. Yeah, it's here. I just have to read my own comments, and then I call a selector that is called select repository list. And then I have a stream, an observable that returns me a list of items. So how can I connect this observable with my state? first let me change the state a little bit of this observable. I use a pipe, and then I use a map operator, and then then I'm losing focus. I delete this line because it's unused, and then I go back. So, value, I take the value and I return a object with the key of list and the value of, let's call the variable also list, then I can get rid of the other value. I return an object that is list, right? The key list with a list of items. Now I have this observable here. Nobody subscribes to it. I delete it. I don't really delete it. I put it in my clipboard, and then I say this. And as I am the state, because I extended from it, I can say this connect state. What is connect state expecting? An observable that returns me partial t. I show you. Observable of partial t. And t is the whole state, so connect state receives a full object of my state or an object that contains only a piece of my full state. So at this point here, I need to put an observable that has at least one key of my local state and a value. And this is the list object that I have here. Very, very cool. The next thing that I need to implement is I need to, I need to deal with this list expanded stuff. So this is not a remote source. This is a local source. This is the click event of my user interface. If I go here and there is this panel, I have list expanded change. Whenever I click the list button, I emit a value. And what I do here is I say I have this list expanded change, and this emits a boolsch value. What do I do with this boolsch value? I again say disconnect, connect state. And there is a second way of describing my, or feeding my connect function. This is a, am I over time? Yeah? Yes? Okay, I can finish it very quickly. So here I have my connect state, and instead of passing an observable with a shape, I can pass a string that describes the key, list expanded. And if I type it right, yeah, the red line disappears, and I just pass any observable that gets stored under this key, list expanded. Boom. I also connected this. Now I have remote sources, local sources connected. I click here, the page refreshes. I have items. I can not click the refresh button, so let me quickly implement the last piece. And now I'm getting really nervous. Refresh side effect $. Okay, so what do I need to trigger this side effect? I can also stop. No. I'm sorry. Hey, I'm just 4 minutes over. What's your problem? Okay, I relax again. This, what do I want to do? I want to refresh the list. Okay, whenever I click, refresh clicks. This is an observable, a button in my template. I take this click, I say pipe it and map those clicks to, not map it, tap it. We want to do a side effect. I receive the click. I realize coding under pressure is not that easy. I imported the tap operator. I scroll down again. Oh, here we go. And then I say this store.dispatch. And then I dispatch, what do I dispatch? Fetch repository list action, okay? This is what I dispatch. So now I have a side effect, and then I can, oh, what should I do to run this side effect? I have to subscribe to it, right? Where do I subscribe? I have hold effect. Hold effect is exactly the same trick as connect state, just it never forwards the value to anything. It just executes it, and whenever the service dies, it unsubscribes. So here I say this connect effect or hold effect, and I pass my side effect in. Beautiful. Now I have my side effect. It's subscribed. I got subscribed to it, and I would be able to trigger an HTTP request, and the list will update whenever my build is done. It refreshes, and I can click this button, and then I will trigger this refresh. But this is not the only thing that I want to show you. I have these intervals. So the last piece, and then you can have your pizza, is I combine the latest values of... no, I don't combine it. You see, I'm so confused, I cannot think. Merge. I merge them, and I merge my refresh clicks, and then I also merge a timer, and the timer starts immediately, and then ticks every, and now I need to go here. I say this, select, I want to select my refresh interval state slice that I manage. Then I say I pipe on this, and then I take its value. Wait a second. Johannes, you confused me.
Don't be.
Okay, I'm back in the game. Last line of code, I promise. I know what I need to do. I take the state from my local state service, and then I forward it to a pipe, and in the pipe I say Switchmap. Of course, everybody should put Switchmap everywhere, because this is the only higher operator people know, right? Do you know anybody else? Any other operator? No. So, and then I Switchmap 2 with my number to a timer that ticks in the number of my refresh interval is set. And this is the last piece of my side effect. Now I will also have auto refreshing when I put here 2000. The recompilation. I never said fuck. And then I put here 2000, so in 2000 milliseconds this component will refresh automatically, or when I click this button. Of course nothing happens here because I don't know. But you know what? It's working. It's just not working now. But I don't want to steal your time. I wanna show.
No, take your time. Finish this one and then.
No, it's okay. I don't want to finish it. You really wanna see me debugging this? Okay. Good. I guess we have pizza. I show you the last slide, and the last slide is a very, very important slide. Are you ready? I showed you a demo. This is the next slide, but on my last slide there is something very important. I say thanks. But for what? I say thanks for spending your time with me for 55 minutes. Most of you are older than 20, I believe, so your time is running, and I'm very happy. I'm very happy that you spent 1 hour with me. Thanks.